Hello again. We're going to be talking about a subject very critical in trigonometry, very underutilized by students. They don't really, I don't know if they don't necessarily understand it or just don't appreciate it, but we're going to be talking about reference angles. And what I mean by reference angles is basically the distance from the x-axis. It's not the distance from the y-axis, it's the distance from the x-axis, the angular distance as it were. And I went ahead and I wrote two examples as angles, the first and the third, and then the second and the fourth in terms of radians. Very important to realize. It can make your life so much easier to understand. I mean, I'll give you an example. Like, there's students who do these problems with a calculator and barely understand and struggle and don't do well. And then there's students who can do this in their head. And I mean, and they think it's this, magic thing. And it's not, and you're actually so much more proficient and you can check your answers so much easier as opposed to relying on a calculator. Quick example, I had a friend, we were taking this class together a long time ago, before college, all that other stuff. And the person had used a calculator all the time to figure out everything, and I didn't. Well, I mean, I'm a math teacher, so obviously I probably did. And even though he was getting the answers initially more fluidly than I was, at least correct, in the end, when the final came and when the exams came, I was the first one done on all this stuff because I learned how to do this, up here. And then people with calculators, if they pressed the wrong thing or, they had to transition something from something to the next, they didn't understand why they were getting it wrong. Why something was negative when they put positive or why something was positive when they put negative. So be wary about that. Anyways, reference angles are the distance from the x-axis. So we're going to work with four different problems. One in the first quadrant, one in the second, one in the third, and one in the fourth quadrant. First quadrant, second quadrant, third quadrant, fourth quadrant. Basic algebra in terms of knowing where the quadrants are. It doesn't hurt to refresh that. So how far is 60 degrees from the x-axis? Well, what we do whenever it's in the first quadrant is just we take, the angle, which is 60, and subtract 0. Well, you don't need to be a genius to know that it's 60 degrees away. And in fact, most students get this one right, like 99.9% of the time. Anything in the first quadrant, they say, oh, okay, that's just 60 degrees from the x-axis. This one, not so much. Sometimes they try to do the y-axis. It's not. It's always the x-axis. Now, how far is this one? This angle from the x-axis. Now, we don't actually go from here because it's either spot on the x-axis. It could be the negative aspect of the x-axis or it could be the positive aspect of the x-axis. Now, when it's in the second quadrant, if it were degrees, we do 180. But it's not in degrees, it's in radians. And in terms of radians, what it is it's pi. So what we do is we take pi and we subtract it by 5 pi over 6. That's all you do. You can't subtract these though because they don't have the same denominator. This is pi over 1. So make sure it has the same denominator. That's 6 pi. 6 pi minus 5 pi is pi over 6. So this is pi over 6 away, or basically 30 degrees away. Now what I have students do is they convert this to a degree. Like if I tell them to put your answer of a reference angle in radians, they'll actually put this to a degree, then take 180 minus the degree, then switch the answer back to radians. And if you feel comfortable doing that, that's fine, but you should be able to know how to switch from one to the other, and if you don't, practice makes better. When it's in the third quadrant, what you do is you take the answer and you subtract it by 180, if it's a degree. If it's not, if it's a radian, it's this subtracted by pi. By the way, reference angles are always positive. So even if you take one over the other, just make it positive. That's pretty much it. So in this case, you just take the degree, which is 240, and you subtract by 180. And you get 60 degrees. If you want to find the reference angle for this one, what you do is we went all the way full circle. Now, if we're here and we're working with degrees, it's 360 subtracted by the degree, but if we're working with radians, it's 2 pi subtracted by it. So this is 2 pi subtracted by 7 pi over 4. Go ahead and, put the same denominator for both of them so that you can actually subtract. It's 8 pi. 8 pi minus 7 pi is pi, or 1 pi, over 4. So the reference angle in this case is pi over 4, which is 45 degrees away. Pretty cool, pretty underutilized. Now some people say, what does that have to do with anything? Well, I know that let's do the cosine. I know that the cosine of 240 degrees is negative 1/2. People are like, what? First of all, what does that have to do with anything? Well, it has a lot to do with everything. Since I know the reference angle, I already know what the cosine's value is. It's 1/2. And all I got to do is look at which side of the x-axis it's on, determine if it's positive or negative. Now, we haven't actually done that yet. And we'll get to that. I'll do that on the next lesson. Well, I'll do that eventually. Maybe the next lesson, maybe a couple others afterwards. But yeah, that's what the reference angle is actually used for. You know, when I see 7 pi over 4, convert it to pi over 4, which is 45 degrees, then I can take the sine, cosine, and tangent of that very quickly without the use of a calculator. Now, if you do that, you're, there's stipulations behind the calculator. It's not perfect. I mean, yeah, most of the time it would be fine, but it's better than learn it. You know, that's the best way I can sell it. But for the time being, that's reference angles. I hope that was moderately helpful. With that said, have a good day. Goodbye.